Thank you to our sponsors for supporting this episode of Troxel, Arc IT, NCARB, and Avail. We'll share more about them later on in the episode. Welcome to the Troxel Podcast. I'm Evan Troxel. This is the podcast where I have a conversation with guests from the architectural community and beyond to talk about the coevolution of architecture and technology. In this episode, I'm speaking with René Morkos. René is the founder of Alice Technologies and the inventor of the world's first generative construction simulator and optimizer. He also teaches at Stanford University's PhD program in construction engineering. René obtained his PhD in artificial intelligence applications for construction as a Charles H. Lavelle Fellow at Stanford, and he is a second-generation civil engineer with over 15 years of construction industry experience that is divided between industry and academia. René's professional experience is pretty wild, and it includes working as a project manager in Afghanistan, underwater pipeline construction, automation engineering on a $350 million gas refinery expansion project in Abu Dhabi, ERP system implementations, and various virtual design and construction projects. You'll hear about a lot of this in the beginning of the episode. Now let's talk about Alice. Alice is the world's first artificial intelligence platform that understands construction, and they're working with some of the world's biggest construction companies to help rethink the way they schedule and manage their projects using AI. As you probably know, the construction management segment can be slow to adopt technology, and the tools that many use for project scheduling and management, like Excel and Microsoft Project, are decades old and not purpose-built. So Alice is a breath of fresh air. Through AI, Alice enables customers to create millions of potential schedules at once and then analyze those options to find the path that best suits their business goals. Companies can save weeks of production time. In this episode, we talk about René's path to Alice via construction sites, both those underwater ones and terrestrial ones that I mentioned a minute ago, and academia, the key elements of construction scheduling and optimization and how AI plays a role in it, the idea of tech as master builder, the idea of an innovation ecosystem, LOD and BIM and VDC, and more. So without further ado, I bring you my conversation with René Morkos. René, welcome to the podcast. It's great to meet you and see you.
Great to be here, Evan. Thanks for inviting me.
Yeah, I'm really interested in what you guys are doing. And I think maybe to set up that problem statement and solution potentially is, how did you get to where you are? I know you have a deep history in construction. I was reading through your bio and it seems like you've gone, I don't know, I don't want to say it like it comes off negative, but you've gone off the deep end on the construction side. You've done, and I think literally, right? Like you've done underwater construction. So anyway, maybe you can give us a bit of your background and talk about then maybe what the issues that you've observed in construction that seriously need to be addressed and fixed.
Yeah, I've definitely gone off the deep end. Yeah, I agree with that. My background, so my dad was a civil engineer. He would always say like the cool thing about his job was that you could kind of point at it, right? And he would drive around town and be like, he was a small time, general contractor, right? And he would point at like, a little villa. He'd be like, I built that. He'd tell you the story of how he met the guy that wanted a villa and so on. And then we drive, to another part of town and he'd point, I built that. He'd point at something else, right? Yeah. And I remember my mom saying like, the nice thing about his job is that, as an accountant, it's hard to point at something. Right?
Yeah.
With civil engineering, like you get to build really big stuff, right? The impact is literally big, right? So in a physical sense. But yeah, like you said, I was always interested in construction. I always kind of wanted to push the boundary, right? So I looked at kind of three options. I had, crisis zone construction, so like Afghanistan, Iraq. I looked at like helicopter construction for ski chalets in Switzerland. That was kind of a thing. I was also looking at underwater stuff. I knew a couple of saturation divers that were sort of down there. They live in these little shells, underneath the water for weeks on end. So I looked at all three options, and I ended up going to Afghanistan, right? But really great experience, professionally, because there's nowhere else in the world that they'd give a 22-year-old, kid, I guess, right? 60 people, right? A couple of, 6 pages of drawings and say, go build a military base, you know? So yeah, so I got to build a lot of stuff. I didn't like school, which is kind of funny because I'm a professor at Stanford, right? But like I would cut class, and my professors, was like, this guy's always cutting class. I was cutting class to go volunteer in construction sites, and I liked it. I liked the construction, right? I liked I like the yelling, right? I like the you got to be a little bit, rough around the edges, I guess, to survive on a construction site. And I liked it. I liked the guys I worked with, I liked the post-work beers, I liked the whole thing. So that's kind of my background.
That's interesting to think about the whole idea of your dad pointing at stuff that's real, physical stuff. I think that is one of the most gratifying parts of being an architect as well, is when you actually walk on the site, when the primary steel goes up or primary structure, and it starts to frame the space that you've designed, on paper, on a computer, and all of a sudden it gets very real. And it's one of the best feelings that anybody who creates things like that could feel. And then how that translated to you fulfilling that kind of that interest in that part of it, that connection to the work. Like you said, like you liked the physicality of building rather than the academic side of things. And I think it's interesting how everybody on the academic, who goes through school is kind of treated like this is how it is. This is the one size fits all kind of attitude. Like everybody's got to do the same things. And clearly you were not cut from that cloth. Like there was just, you had to find that thing that served your purpose, and you found that the fulfillment in the making of working through construction.
It's interesting, like when you were talking, my hair literally stood on end, like that. And for me, it's the concrete pouring.
Yeah. Okay.
When you pour the concrete, like I've rarely been happier when I go home and I got the concrete flecks in my hair. But there's something magical about, like, that column wasn't there. And I remember really thinking this, right? The column wasn't there this morning. Now it is. Right. And it's going to be there.
I poured some concrete a couple of weeks ago and I hated it. I really literally hate pouring concrete. I was putting up a fence, putting in fence posts. Like you're saying, that column wasn't there yesterday. It is gratifying to see it go up so quickly. But at the same time, man, I love framing. I love the enclosure of space. That's my side of things. Yeah.
But the thing that you were pointing out is correct. And it's interesting. Like that's the thing that really is, I think, remarkable about a place like Stanford, which was the answer is always yes. And it's the first time like I've encountered that, which was like, you're right. I never really fit in, right? I've rarely fit into any of the institutions I've been in. I've always sort of, tinkered with stuff, been outside the box, like wanted to go build in war zones. Like, it's, but when I started my PhD, I sort of said, hey, I want to spend 6 months a year working. And it's, I would imagine most professors in the world, would be like, no, what do you mean? You got to sit here and publish papers, right? But Martin Fisher at Stanford was like, great, knock yourself out, right? And he basically said, go do it. It's colloquially known as an industrial PhD. So you do 6 months on, 6 months off. But I sort of bounce between, I'd go to the field, tinker with stuff, and then go back to the lab and kind of, build the next thing that I was going to tinker with, right? I think that's why the end result was so applied.
So take us, how did you make the leap back into, like you said, self-proclaimed? School wasn't for me early on. And now you're talking about going after a PhD at Stanford. How did that bridge get built?
It's a great question, right? Because the 2 points are contradictory, right? But I'm half Czech, half Lebanese, right? My mom's Czech, my dad's Lebanese, and so I think I quickly started to understand that like mixing two worlds can result in some really, really valuable and cool things, right? And vice versa. You can have, you can pick up advantages from both worlds and you can pick up disadvantages from both worlds, right? But like what I realized was that, if you were to be an artist, right, then you'd think, oh, well, an artist is just paints. But, if the artist has a strong mathematical background and brings math to their art, that's valuable, right? Vice versa. If you got an engineer and the engineer, just simply is like, oh, all I do is numbers, but you have an engineer that's creative and a little bit artistic, right? That is valuable, right? And so what I kind of knew was like mixing worlds together was useful. And so my dad got a PhD, so I think that sort of helped. And what he said was it taught him how to think. And for me, what I thought to myself was I was 22, I was given all this responsibility, all these people, and look, I got things built, but I really quickly realized, like, hey, I am not a professional. Like, there's got to be better ways to do this, right? I have my own methods, right? But somebody somewhere has probably figured this out. And so I went to USC, got my master's, and I kept looking for this, like, because I was so aware of the problem, I kept looking for the software or the tool that would solve this problem. The problem being is how do you sequence work on a construction site? USC taught me Primavera, taught me the fundamentals of estimation, of scheduling, of planning, of all that stuff, right? But it didn't give me this thing that was going to solve the problem. So I thought to myself, okay, well, why don't I go to Stanford and go get it there? So part of me wanted to go find this solution that I was looking for, right? Part of me was kind of inspired by my dad, who was like, look, I mean, you don't have to use a PhD. It teaches you how to think, right? Part of me thought to myself, like, hey, this field needs some level of innovation. Like, I didn't realize I was going to end up working on something this impactful, this substantial, right? And so I think that combination of stuff, right? At the same time, like, do I enjoy sitting and thinking about stuff? Yes, right. I guess maybe I'm realizing in this conversation is like, I don't like people telling me how to think, like, that's definitely a no-no, right? Yeah, like thinking like by myself in a room, yeah, I'm down for that. So I think that combination of stuff led to doing a PhD and led to me doing it the way I did it, which was this 6-month on, 6-month off program, which...
It's interesting. You have like this bifurcated life. The two examples that you gave are very, the artist with the math background or the engineer with the art, like it's very left brain, right brain balance. And then you also talked about kind of this, you're being taught the ways that people already address these issues. And you obviously had experience on the job site, which was very kind of a street smarts versus book smarts kind of a thing. And so you go to school, you have the street smarts, you go to school to get the book smarts. You've got this very left, right, kind of thinking balance going on that you're trying to achieve. It seems like even the 6 months on, 6 months off, like I'm just seeing this pattern over and over in everything that you're saying. Yeah.
And it works. Yeah. Like the thing is that here's what I realized was that whatever you do in life, people will try to box you into something. Like you're an estimator. Oh, okay. So you're good at estimating and you're good at spreadsheets and looking at data and crunching data, right? But, my sort of 2 cents is screw what people think, right? Like if people think that you're an estimator and so that you're good at basically crunching lots of data, it's like, okay, but if there's an artistic side to that data crunching, it's going to make it a lot more powerful, right? And if anybody, if any of the listeners have read Good to Great, it's kind of like one of the most famous kind of books in Silicon Valley, right? It's kind of the Silicon Valley mantra, right? Jim Collins, Good to Great. But he's got one chapter in it that he calls the genius of and. So like a lot of companies are like, are we going to be fast and nimble or, slow and steady? Are we going to be, and there's always this kind of like, well, do I do A or do I do B? And he realized that a lot of the successful companies do both. And so that's kind of, I think, part of what you're seeing here, which is like, well, let's do both, right? Let's try bring. And one of the things that I kind of also have thought about a lot is that oftentimes the difficult things in life require 2 opposing characteristics. Like to be a good leader, you have to be liked and respected. To have a company, you've got to be able to be fast and quick, but you also need to have a plan that everybody's sticking to, right? That they're pulling in the same direction. So oftentimes you do need these two opposing yin and yang kind of, energies. So it's really interesting that you've uncovered that. But yes, it has been a very strong part of my personal, I guess, life philosophy, these skating it between worlds, or switching and combining two opposing ideas or philosophies or whatever.
Well, and then like you said, you by understanding both sides, you can connect the dots that exist, and I either identify things that are missing or things that are working in a much more holistic way than somebody who specializes in the one thing. So you're kind of giving yourself an advantage by being a bit more of a generalist than a specialist in that sense, because you have the ability to see it from these different angles.
I don't think you could like, what's interesting is that you, like, let's assume, world A, world B. Without world A, you wouldn't be able to make the progress in world B, and vice versa. But what's interesting is, because of world A, you make that progress in world B. Because of the progress in world B, you can now make progress in world A. Right? And
they need each other.
Like when you look at the way that I did the PhD, which was, I mean, I literally I had a job, right? And so I was consulting. And what was clear to me is, like, these folks were not going to pay me for some research that might pay off in 4 years. So I was a consultant. I would consult, and it was like the funnest job in the world. I loved it. Like, it was so much fun. Like, I was responsible. I was like the VDC guy. I was responsible for bringing in like BIM, VDC, building out the ERP system, the cost codes, daily reports, that kind of thing. And when everybody would go home at 5 p.m., I was like, now's my time. So I would kind of dust off my research and start tinkering around with these concepts and ideas, and then prototypes, right? Then I would go to site and start running it and like get data from the site. And in the evenings, I would be sort of running the research. And then I'd go back to school. I was like, great. Now I've got all the data and I see where the prototypes have failed and what really didn't work. Now I don't have a 40-hour work week where I've got to focus on creating value for this company. I can now go and tinker around with the prototypes, and this is what didn't work. This is what broke. That's what the guy on site told me. Here's really like the real life feedback, right? When you took it into the battlefield, so to speak, right? And now you're sort of learning all these things. And so I'd come up with V2 of the prototype and go back, and you're kind of seeing that one can't really exist without the other.
Yeah, that's interesting to think of it that way. And again, it kind of gave you agency, even though I don't even think it's worth getting into whether it was kind of quote unquote sanctioned by the company that you were consulting for or not. Like, you had the agency to go in and try to solve these problems because it served this other need, but you knew that they were going to make each other better over time, rather than just kind of pontificating if, like you said, you didn't want to come up with something that might make them money in 4 years. By actively prototyping it along the way, you were either proving or disproving. Either way, you were coming to a sharper point of conclusion that was going to matter and make a difference, and you were doing it through doing it, right? Instead of just talking about it or thinking about it.
Yeah, absolutely. Something that I've noticed about the Bay Area in general, so Silicon Valley or the Bay Area, like, what's kind of interesting is that culturally, like, here's another thing, right? So, mom's Czech, dad's Lebanese, Middle East, Europe, super different cultures, right? Both have advantages, disadvantages. American culture has advantages, disadvantages, right? But then the Bay Area, for example, like, something that I very quickly picked up was that I was dating a girl from the Bay Area, and I needed a desk, right? And this girl literally, gets in her car, drives to Home Depot, buys a bunch of wood, comes home and builds the darn thing, which like just blew me away. Right. But the doing part, like just go out and do it. Right. And that's a very like Bay Area thing. People don't realize, like, it's part of it's in the water, right? Like, you go to a party and people, like, it's somebody's birthday and they'll build a rocket ship out of cardboard boxes. They're always like doing stuff. Right. So I think I kind of picked that up as well.
Yeah, that's great. I love that story. I'm wondering, maybe we can segue into kind of the issues that you saw. You alluded to it earlier about scheduling and phasing and all those types of things. I mean, it seems to me like you saw a lot of potential inefficiencies in there. And then you also mentioned something about how without having these kind of two very different worlds that are colliding or overlapping in some way, you don't get the insights. And I think that's something that we do see in the profession, in the building industries, right? The construction industry, architecture, where it's very easy to just stay in your lane and do it the way we've always done it. This is the way we do it. This, the famous quote, you hear it all the time. This is the way we do it. Why? Because this is the way we do it. And I'm sure that because you had a foot in each one of those worlds, you really saw, and through your previous experience working on job sites, right? You saw those opportunities or those challenges, however you want to frame it. And that gave you insight to actually attempt to fix those. So maybe you can just speak about the kind of the challenges that you saw within the construction industry and how that led to the pursuit that you're on currently with Alice.
Yeah, so I think that there's two fundamental there was two moments, right? I wish there was one. It would make the story so much easier, right? But there was two. So I'm given my first real project, right? So believe it or not, the first project I got in Afghanistan was building a bar out of a crashed airplane, right? So the second project I got was building landing strips for F-16s. So the second project I got, I'm there.
It's a little bigger.
Yeah. But I was sitting there and trying to, like, it was, sun was rising, it's 5:30 or 6 a.m., really cold. I'm talking like 10 degrees Fahrenheit, minus 10 Celsius cold. I'm trying to figure out how to sequence, my guys on the site. And I'm rapidly coming to the conclusion that, like, it's not that easy, right? It's like, well, if you put, because you can also change the crew sizing. So you put like 5 people here and 3 people there, and these guys are finished before those guys will, but then you got rebar and you got steel and you got masonry. And then so I'm sitting there trying to piece this together, right? So I'm like, man, like, I don't know, maybe I'm stupid, right? But I don't intuitively know, like, this is the optimal. I have a solution. That's not hard. But I don't know if this is the optimal solution, right? This is the fastest way to do it, right? And so I'm not thinking in terms of cost. Labor is not very expensive, but this is the fastest way to do it. And I assure you that the major that was running the base was very clear on the fact that this was something that he wanted done quickly, right? Because you've got about a third of the capacity of the military base that's being affected by this construction. That was the first moment, right, where I sort of thought to myself, like, hey, like, I wish I had some sort of software that I could say, hey, look, here's the number of people I have, here's what I'm building, and you go crunch everything for me and then come back and tell me how to do it, right? I didn't realize that didn't exist, right?
And how did it exist at that point? Rather, because it's very Wild West, right? It's like everybody does it differently. Some people are doing it in Excel. Some people are doing it on a sheet of paper. Some people just, like you said, kind of have this intuitive knowledge of what it's going to take to get something done and how long it's going to take. And there's all these logistics happening as well, right? There's deliveries and there's supplies and there's who knows what to do in those different areas. You're not going to just say, okay, 5 people on this crew, 3 people on that crew. Oh, let's change those numbers. They don't necessarily have the skills that are needed to do the other thing. Sometimes they do. So there's all of this kind of these variables in the process as well. So I maybe you could just speak for a moment on some of the experiences you saw in how people were solving it and maybe how that reinforced how broken it actually was or is.
I mean, that's exactly, what you were saying, right? Like, there's this sort of archaic kind of almost like shamanic kind of magical, mystical knowledge, right? That the sort of somebody serves up at a construction site and they go, well, I think, and using my gut sense, my experience and so on and so forth, here's how we can go about building it. Our industry has, 98% of large projects are 80% over budget. That's our average performance as an industry. So how good is that working for us, right? The thing that one of the reasons people think that what we developed at Alice isn't possible, right, is that Alice, like, it's exactly what you're saying. Like, there's too many variables. There's too many. Like, how would you possibly put all of those variables in a computer? In around 2011, I made what was arguably the bet of my life, right, on the fact that Hell no. Like, I've poured concrete columns on 4 continents, right? In 5 or 6 countries. There is only one way to do it. I don't care if you're in Bangalore or Dubai or Chicago, there's one way to do it, which is you put the steel, you put the formwork, you pour it, you wait for it to dry, you remove the formwork. And so that sort of pushback was like, no, I disagree. I don't think that as an industry, we have the option to say, oh, it's too complex, it can't be done, right? Like, how many papers have I read where it's like every single project is this magical, mystical unicorn that's never been done before, and it's a completely unique, production line. We're effectively building unique factories out in the middle of nowhere for things that have never been done before, right? And I've read like
it's always been done before,
and I've read this thing like I'm telling you, if you are a construction sort of researcher, like every second paper you read has this exact same line, right? In some form or another. It's like, projects are unique and it's a unique, production facility that we built, blah, 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 right? And it's like, I was like, no, I know that for reinforced concrete, which I have a lot of, experience with, that I swear to God, there's one way to do slab, one way to do a column, maybe 2 ways to do a slab, one way to do a column, it's maybe 3 ways to do a staircase. Like, there's not that many options, right? And so I bet on the fact that, like, what I thought to myself is like, it can be done for reinforced concrete, right? Like, I know that, right? I don't know if it can be done for everything else. It turns out it can be done for everything else, and it can be done pretty easily. But the bet that I made is you can boil down this complex construction constraint, rules, all this sort of like very complex stuff into relatively simple, repeatable rules that the computer can understand. And it turns out not only is it doable, but get this, it's doable with 3 rules. This blew me. Like, when we started this, I thought to myself, I know the 3 rules, right? If there's like 6 or 7 in total that we need to do this, like boil down all this complex construction sort of world into algorithmic terms, right? If there's like 6 or 7 rules, we'll probably pull it off. If there's more, we'll probably run out of money. And it turns out there's 3, right? There's 3 things that basically, that boil down all that construction complexity, right? Which is sort of interesting, right?
So what are the 3 things? You can't leave us hanging like that.
Well, it's relatively simple, right? Like, if I had $1, right, for every time I heard the following statement, I see how Alice could work on that kind of project, but it would never work on my super secret magical kind of project, right? And it's like, sure, but when you think about it, construction, like all of construction, is effectively building elements that are constrained by physics, right? They sit on top of each other, right? They need tasks and resources to be built, right? That's your pattern. If you boil things down to elements that are constrained by physics, that need tasks and resources to be built, that basically starts to show you that, like, what's kind of interesting about Alice is that it technically works on anything. Like, we've tried it on high rises, bridges, data centers, tunnels, roads, et cetera, et cetera, et cetera, right?
Wow. And it works on all that stuff because of those kind of 3 rules that you're talking about.
Yeah, the 3 rules are the following. The 3 rules are precedence, so logic. Certain things have to happen before other things. You don't want to build a roof before the foundation. You don't want to paint your wall before you've poured it or cured it, right? So precedence is rule 1. Capacity. So you don't want to schedule 6 concrete tasks when you only have 2 crews, right? You don't want to schedule 2 crane lifts when you only have 1 crane, right? So precedence, capacity, right? Space. Space is that you don't want to schedule things to occur in the same space at the same time. And so space is a form of a capacity constraint, right? It's interesting because it has a capacity equal to 1. There's only 1 space available that you can dish out to construction processes. But you kind of, maybe, right? But hopefully, like, you start seeing how you're starting to translate this thing that is like, it's super complicated, into stuff that is starting to sound a little mathematical, right? What happens before what? Don't exceed capacity. Don't schedule things in the same space at the same time. Like, those are mathematically tractable statements. right? And so that's kind of the trick. You asked me for the second thing that I saw. So the first was this construction site, sun's rising, cool background, but it's a slab, right? And so that was the first thing. It was like, hey, like, is there some way that this could happen for me automatically? The second observation was construction sites are empty. And so I'm on the cruise ship terminal in Amsterdam, right? And we're building the cruise ship terminal. What's interesting is that the project is 6 weeks late, right? And it's 6 weeks late. Every day is 50,000 euros. And these, Dutch people are generally like reserved, but they are now angry. There's a lot of stress, right? As I'm sort of picking up the stress, I sort of think to myself, hey, why don't I just kind of step back? So I step back away from the table, go to the window just to kind of get a little breather. And this subcontractor is kind of banging his fist on the table, like, I cannot work any faster, right? And I'm looking outside the window, and I see 100,000 square foot of space with 6 people in it. And I realized that every construction project, and the cool thing was that I had been on, about 15 at that point, every project I've ever been on is empty. And so I suddenly realized, like, holy cow, like, think of a project, like, when you look at it, there's maybe a pocket or two of work, but the rest of it is just empty space. So I started to measure what percentage of construction site space is used for construction on average. So would you like to hazard a guess at what that number would be?
Well, just based on what you're saying, I'm going to say it's like 1 or 2%. 3?
I did the experiment once in the Netherlands, twice in the US. And the way we did it was we would take photos. Each 4 columns was a bay, a zone. And we would just measure whether that zone was occupied or not. We started by measuring whether people were working. The number was so low that we're like, if someone's standing in there and just kind of staring at the ceiling, we'll count that.
That counts, yeah.
But the number was 3%. And so 3%, right? And of that 3%, like, what's actually, so then it's like, that is a remarkable statistic. Because what that's telling you is that, hey, other, like, asset utilizations in other fields, 40, 50, 60 is an operation, maybe efficient operation, 70, 80, right? But 3? So it's like, okay, well, how do you increase space usage? You schedule more things at the same time. But when you think about it, scheduling more things, if you have the area of each process, let's assume it's like a square, and you look at the top-down view of a construction site, the way that you put those squares on the construction site can change the setup, right? Sometimes you can sort of say, I'll do A, B, and C, or maybe, instead of B, I'll do D and E, right? So the configuration is the word I'm looking for, changes. And so because the configuration changes, like, you can either do it manually, which seems like a real pain, or heck, we're in Silicon Valley, why not use an algorithm? So we had an algorithm that would automatically reconfigure the space usage on a construction site and try to increase it. And so that's, that's where it led, because when you have an algorithm that configures space on the construction site while satisfying logic precedents, you start to have an algorithm that can build. Not very well, but that was, I went to my advisor and I showed him the results, and he said, did you validate it with a project manager? And I said, well, but the project manager's in Amsterdam. The answer was, I don't care if he's on the moon, get it validated. So I called those guys up. I said, hey, you guys want a free week of consulting? They're like, yeah. I was like, you want to buy me a plane ticket? I said, sure. That was cheeky. So I showed up there, and then I did a free week of consulting, and I talked to the guy that was on the project, and that's where he was like, yeah, it works. Like, the schedule that the software produced is buildable. That was the moment, right? I was like, wait a minute. So I'm back on the plane, sipping on a Heineken, and I'm going like, wait, this thing knows how to build.
Achievement unlocked right there. Like, the validation happened. That's awesome. Let's take a quick break to share more about our sponsors. Arc IT. You may be doing IT yourself or have someone you trust doing it, so why would you even consider switching IT providers to make technology your competitive advantage anyway? Well, many of you don't feel like you're getting enough value from your current IT provider. Some examples of this include slow response times for critical issues, the inability of your provider to answer key questions that you have pertaining to your business, the same issues showing up over and over without long-term solutions to the root of the problem. And it's just likely that they're doing an okay job and you'd rather avoid a difficult conversation with the people already in place. Well, the truth is, okay doesn't cut it, and the right IT provider can make a meaningful difference in your day-to-day work experience and in the bottom line of your business. It's also key to remember that you are in business to make money, and the right IT provider can help. A great IT provider takes on the load of managing the transfer process so you don't have to worry about it and you can concentrate on running the business. They take on all the work with onboarding through the allocation of their resources and include you in the critical decisions along the way to minimize your time away from billable work. So, as business owners and architects, how often do we think about our IT provider? Typically, only when things go wrong. And for many of us, unfortunately, this happens too often, especially with the latest emphasis on remote work. I know that I've had to deal with my fair share of IT fire drills. Not pleasant. ArcIT, however, is a very different kind of company. They specialize in serving architecture, design, and engineering firms, and their goal is to help you use technology as a competitive advantage. This means that they understand your technology stack and they won't waste your time and money learning how your tools work within your process. Combine that with industry-leading response times, proactive remote hardware management, and solid disaster recovery and backup solutions. That's something that everybody should be thinking of, honestly. And enterprise-grade security management. And yet, above all, these are just table stakes for a solid IT company. ArcIT goes a step further. They become your strategic partner when it comes to planning, budgeting, and integrating new technology into your business processes. So all of this sounds expensive, right? Nope, because ArcIT is highly specialized. For our industry, their pricing is on par or in some cases even lower than other IT providers. ArcIT is transparent and even publishes the pricing right on their website. Speaking of their website, there's also something else you should check out when you're there, and that is their Design Under Influence blog and video series. Again, adding value to IT-type solutions across industry, all good stuff. So your business deserves a competent, responsive, and proactive IT partner. Reach out to my friends at ArcIT for a free consultation. So go to getarcit, that's getarcit.com, arc like architecture in the middle, and click Work with Us. Let's talk about content. What is content? You're probably thinking Revit families. Well, yes, of course, but the reality is that you use dozens of applications in your workflows. How many file types and formats are you using and creating every week? Here's some of the usual suspects: CAD and modeling files like AutoCAD, Civil 3D, Rhino, and Revit and SketchUp, visualization files like 3D Studio Max scenes and models, materials, and assets, photos and imagery, including renderings, site context, and snapshots, project information like spreadsheets and product cut sheets, URLs for your intranet and external websites, and even marketing assets like your PowerPoint decks and proposals. I wish it wasn't true, but this list just scratches the surface. You know what I'm talking about. We all deal with a lot of data, and this is the new problem. The good news is, if it's digital, Avail can handle it. Avail has seen more than 1,000 different file types in their platform. They've taken a very holistic approach to content management problems in the AEC market. Most of the time, someone in a firm is looking to solve a specific problem like Revit family storage, but the fact of the matter is that you should be solving for the longer term. Avail future-proofs your technology investment. Go to getavail.com today to learn more. NCARB's Analysis of Practice Study is your opportunity to shape the future of architecture. Participate in this industry-wide survey to share your experiences and insights from working in architecture, engineering, or construction. Your feedback will help guide changes to what being a licensed architect looks like and impact how architects collaborate with other professionals in the future. Whether you're an architect or you work with architects, NCARB wants to hear from you. Make sure your voice is heard. Contribute to the Analysis of Practice Study today. Sign up at ncarb.org/AOP. And now let's get back to our conversation. So this led to Alice. Maybe you could just tell us what Alice is, and because I think one of the things I want to talk about here, there's two things I want to talk about. Number one is them basically validating it and saying it works. But then there's this whole mindset shift on the construction side that has to happen to accept it and actually do it, right? And I imagine there's a lot of roadblocks there because I see a lot of roadblocks with implementation of technology on the architecture side as well. But then I also want to talk about kind of bridging back into the architecture side of things, because there's so much about logistics and sequencing and phasing and all these things that architects don't understand because of, the we're keeping means and methods far away from us, right? And we don't want to get into that. But we all know that these things that we're drawing are linked. They're hard coded to sequencing and phasing, right? So how does the stuff that you're working on work its way back into the planning and the design intent side of things to really see the full potential of something like this? So I put a lot out there. I would love to, if you could just start with what Alice is and what the basically, you just got this verification to happen and how that led to Alice.
So Alice is an acronym. It stands for Artificial Intelligence Construction Engineering. We thought it sounded better than ACE, right? So, but Alice is the world's first generative construction simulator, right? So it sounds like a bit of a mouthful, but the way I explain generative construction is through an example of parametric design, right? With parametric design, let's assume that you draw a cylinder. You draw two circles in a plane. Let's say you want a bigger cylinder, you redraw it. A smaller cylinder, you redraw redraw the object every time there's a change. If the tool is parametric, as you might have guessed, you got a height and diameter parameter. You change the parameters, and the tool redraws the object. The way that this has been played out in design over the last, say, 30 years, right? BIM, right, which is a big thing in our field, is two technologies. It's parametric and it's object-oriented. Right? So software understands it's a column made of concrete on the third floor. And if you change the column height, then all the columns in your model change, right? In the last 3 to 5 years, we've seen the advent of generative design, right? So what I talked about was parametric. Generative, what does that mean? Well, I, the human, don't want to change the parameters one by one. I want you, the computer, to change all the parameters for me, try all the options from 1 to 1,000, and give me the option that has the greatest power output, the greatest rentable area, the minimum energy requirements, or whatever it is, right? This has never been done in construction. So that's what Alice is. Alice is a generative construction tool. It actually builds your project for you tens of thousands of ways before you need to go out and build it. The trick, right, so to speak, and this is the part that, like a lot of people are like, well, how does that work? Like, I don't buy it. That's bullshit. It's never gonna do anything useful. It does work. Here's why. The trick is that what we did was we separated planning from scheduling. And in our field, those two things are used interchangeably. Planning is setting up the rules that govern your project. Scheduling is crunching those rules. What we've given the human is a translator, a language, so to speak, in which you can tell the software what the rules are. Now, it sounds very abstract, but it's actually really simple, right? Like, I'm building this building. Which elements sit on top of which elements? That's one rule. I'm going to group these columns on the third floor into one group because I'm not going to manage them column by column. And then the third rule is what we call recipes. So what tasks and resources do you need to build a column? These are all very standard piece of information. Like, you could wake up a construction person at 3 a.m, and be like, how do you build a concrete column? Or, how do you, build do the finishes in this hospital room that you're working on, right? And they'll say, okay, these are the 5 tasks we have in our schedule, right?
Yeah, it's muscle memory.
Yes, right? Exactly. So it's a very, very like standard stuff. There's nothing in the software that people are unfamiliar with, right? There's stuff that like materials, for example, you can define as consumable or reusable, right? It's kind of like, to the contrary, like maybe you're not using it on a day-to-day, but like, oh, that's kind of cool that I can do that, right? Or radii, you can just define the radius of a crane, right? Which is also kind of cool, right? So that's basically how the setup works. set this thing up. The software crunches all of these variables for you, right? Gives you automatically generates 4D model, schedule, etc. that you need.
And what does it need to start with? So, if again, coming from the architect side, right? A lot of people are building a BIM model, and they're cutting that up into 2D representation so that they can get a permit, right? And it's not necessarily what a contractor needs. So I'm wondering how you kind of bridge the gap. Like, what do you need to start with, and how flexible is it? Because again, like if you're a contractor, you're working with a different architect every single time you do a building. So you're going to get a different input every single time you build a building from the architect, not to mention technology changes over time. So a lot of variables there as well.
Great question. So let me maybe the question you're asking is in what the inputs are changing. You don't always have all the data. The level of detail is changing, et cetera, et cetera. Here's what I can tell you. There is no project in the world that has all the information. It doesn't exist, right? Second, I've spent a lot of time, reading a lot of research, and there's this sort of idea out there that like we're going to reach a point where there's this like one central model, right? That has all the information, right? Like this is kind of one ring to rule them all, and Lord of the Rings thing. But what I've seen over and over again is that the architect is worried about the architectural model.
Right.
The structural
100%.
engineer is worried about the structural engineering model.
Different purposes, right?
Exactly right. So you're going to build a model that's going to solve the problem that you're working on, right? What you'll see with Alice is that Alice, you can use it either with a 3D, with a BIM, or with 2D. Right? If you set up Alice with 3D, what you set up is what we call a CIM, a construction information model. So you tend to have a much cruder LOD 200 version of the BIM that you input. So what we tend to see is you could use the architect's model, but the architect's model tends to have too much detail. It's way easier to create a crude, like boxes, 10-story building, put 10 boxes on top of each other, right? That works well. And so what we tend to see is people create these much faster, much cruder sort of models than the architects. And so you can use 2D, you can use 3D. The thing that's interesting about Alice is that I guess the first point I was making is that you can, whatever problem you're trying to solve, you will create the underlying model that will solve that problem, right? And whereas what we've seen is you can reuse the architect's model. It's really way faster. Just create something very simple, put some boxes on top of each other, what we call like a schematic kind of diagram, and run it that way, right? That tends to be enough. The other thing that's sort of interesting is that as information comes in, because that the level of detail of the information becomes finer and finer as you move forward in time. So Alice follows what we call a dynamic LOD approach. If we were static, i.e. I came to you and I said, well, for you to run Alice, you have to give me exactly this information in this format, you'd be host, right? There's very few projects in the world that would satisfy that. But
nobody would
follow
it. Yeah.
But what's interesting is with us, you can sort of say, well, I don't know what the basement construction is going to look like. So I'm going to have one task that says basement construction 45 days. A little bit down the line, we suddenly now have the basement contractor. And the basement contractor says, yes, well, I'm going to break down the basement into waterproofing and concrete construction. These are the 4 or 5 phases. And each one of them is going to be 2 weeks. So you can set that up in the recipe, right? And the thing that's really fascinating about a rule-based system is that you add the rule, and the rule-based system, like, you don't have to rethink the whole thing, right?
It just pushes it through.
Exactly. It propagates that change for you, right? And so it's really, really cool because it's like, hey, here's a good one. The design changed.
What? That never happens.
Right. Exactly. It never happens, right? But with a system like ours, get this. You upload the new design, say, copy the rules from this old design, right? And once you do that, what the software will say, okay, I'm going to copy the rules. And it's going to say, hey, these elements, these things didn't change. So I'm going to copy the rules. This is the changes that you made. You added a floor, right? What do you want to do about it? And you could say, well, use the same rules as for the prior floor. That takes 3 minutes. Alternatively, maybe that new floor is completely different. Well, you got to create the new rules for it.
Seems to me like this would be most beneficial throughout the process of design so that everybody kind of knows on some level what's going to happen, right? And be able to have an educated guess about how it's actually going to work out, weather withstanding. And, there's going to be other things that work their way in that are going to screw up the schedule that everybody deals with on every job site. But it seems like this would be really great information to have as early as possible to be able to. It just doesn't seem like that's the way people operate, right? Though these silos are pretty separate depending on. I guess I'm thinking from my own experience, which is public bid type stuff, which is the contractor is selected after bids are received, after the design is already done, after the decisions have already been made. And the stuff that you're talking about would be really advantageous in a design bid or a design build situation or an IPD situation.
I don't think that Alice is trying to get people to change what they're doing. I think that the level of effort to create a simulation, so I don't like to call it a schedule because a schedule isn't a simulation. It's not resource loaded. Doesn't account for the design. It doesn't account for a bunch of stuff. Like the effort required to build the thing, several times before you build it is, 800 times less. And so if that's the case, then my opinion is that yes, if it's a lot easier to create detailed schedules, then why not do it up front, right? And so we are seeing examples where our clients are being brought into the design charrettes because of their ability to rapidly propagate design changes through their system. So we're seeing that.
Seems like this kind of thing should be free, right? Just like I think like drawings should be free. You're building this incredible BIM model, right? With all this intricacy potentially in it. And the drawings are just an output. They're a side, it seems like this should be kind of thought of like that as well. Like you said, it's so easy. It should be free.
You've told the software you've told us, Alice, how you want to build it. That's the thing. So like there's a misconception. It's like, it says AI in the box. So I'm going to say, how do you build a hospital? Like it doesn't work that way. The value of an architect is not creating copies or blueprints. Is that they understand light, space, and materials, and right. The value of a structural engineer isn't in sitting there with a calculator and crunching finite element analysis. They understand how structures work. They know how to set up the software that can crunch all those variables for them. The value of a construction engineer is not constraint satisfaction. It's mind-numbingly boring. I don't know anybody that's like, oh, I'd love to spend my time sitting here doing resource allocation. But the part that Alice enables is fun. The software is like, hey, Mrs. Construction Engineer, have built a lot of columns. How do you want to build columns for this project? And it's like, well, like, here's an interesting one, right? Like normally you say, well, I'm going to do rebar, then formwork, then pour the concrete, then strip the formwork, right? Like recently I saw a recipe where somebody had broken down. They said, formwork on one side of the column, right? Then there was some, task, formwork on the other side of the column, right? Like that's kind of what the construction engineer is doing for you, right? And in my opinion, that is the value of a construction engineer, right? Let the machines do what the machines are good at. Let the humans do what the humans are good at.
Absolutely. Yeah. So how does this, once you kind of prove it to somebody, I'm sure that you do a lot of proving to people because you probably get a lot of pushback like, oh, this isn't going to help me. Two things. What is the value proposition that we're actually talking about here? I know you guys probably have some statistics about what is possible by implementing something like this or this specifically, but then also what does it actually take to change to happen in the construction industry to adopt this so that value can be realized? And are people ready for that?
So the value proposition is that using this technology, you can save about 17% on duration and about 13% on labor and equipment. This is not very surprising. The pattern that we have noticed at Stanford, so my advisor, the Professor Martin Fisher, what he's seen sort of over and over again is like, if you can run something in a computer many, many times and compare it to running it by hand, then you'll see about a 20% improvement in performance, right? That's sort of a rule of thumb, so to speak.
Yeah.
So,
But people's businesses are not built on being 20% better, right? Like there's just naturally some pushback to just say, well, that sounds great, but I actually have to change how I work to realize that. And that's a big thing to bite off. And construction segment is slow to adopt technology, just like architecture is slow to adopt technology. I even think construction is probably better at it than architecture. But what is that kind of mental shift like? Is it happening? I guess that's my question. Is it happening?
So I think that we're living in the most exciting time in construction in probably the last 2 millennia. Right? What's happening to construction today is what happened to manufacturing in the 70s and the 80s. People say construction is not innovative. I think that's bullshit. Let me tell you why. The reason that construction is one of the last to digitize is not because we are, lazy and dumb and whatever the heck people say, but it's simply because the thing that we're trying to digitize is much, much harder to digitize than a lot of the other fields, right? If you think of, let's assume, we were back in the 60s, right? And we went about to digitize something. What would be the first thing that you would think is like, hey, let's go digitize that? And I have an answer for you. Probably banking, right? Because how hard is it to digitize a bunch of numbers sitting in an account that are moving around, right? For us to digitize construction, we first had to digitize the input to construction, which is design. The thing is that what I can tell you is the reason it has taken this long is not because the technology didn't exist. Mechanical engineering, parametrized design in the 80s, PTC did it. The issue was that buildings as models are bigger and more complicated than engines. And so it took till really, 2010s for the machines to be able to crunch these parametric models. And I read this, AEC Bytes from Lakshmi Kimlani had this blog that I read years ago where she talked about it. And when I started my PhD in 2009, the big question was like, oh, BIM's this big kind of cool thing. Like, how big is your model? I don't know if you remember that sort of era, right? It was like, and Bentley was like 150 megabytes, right? These giant models, whereas Revit was like doing these like 3-story buildings. Bentley was following a federated database approach where your windows are in a different file than your slabs, which are a different file than your staircase, and that made you could have much bigger models, but the parameterization, the ripple through of those changes was much harder. Revit had everything in one file, right? And so that's, what you're seeing is that the machines really started to catch up recently, right? Where you can start crunching these large sort of complex models, right? But so to answer the question, like, it's just taken this long for the technology to catch up to be able to digitize it, which is why what we're seeing, what is happening is what we're seeing, right? Because so 2017, I think, was the break point where suddenly a bunch of venture capital flooded into construction, right? As a result, there's a whole bunch of companies like ours, right, that are really shifting the technological frontier of what is possible, right?
Mm. So when it actually comes to, okay, so the technology's caught up, I think we could probably have a long discussion about purpose-built technology and whether it's there for the new purposes that we're talking about or not. But I'm still interested in kind of the human factor of change and what is it being accepted, adopted, implemented, things like that, readily, openly, or is there still hesitancy in that?
That's a great question. Here's what I can tell you, right? Every single industry has people in it that are innovators. Every single one, right? The beautiful thing about innovation, and I'm sort of paraphrasing, I think it was Jeff Bezos that something that he's like, if you want to be innovative, you really need two things. One, an incredible amount of perseverance, to stick through failure. Two, the ability to ignore people that laugh at you. Right? But the advantage is that if you innovate, you have a competitive advantage against other people that will enable your business to perform better. With the advent of time, innovation is never, in my opinion, something where you can just kind of go and first thing and it's done, right? And so to answer your question in terms of the adoption, like, we are seeing adoption, right? Is it something where, hundreds of companies are like, clamoring to like immediately change everything they're doing? No. But name a construction company today that doesn't have a head of digitization or head of innovation, right? All of them do. Name a construction company today that doesn't have some strategy in how to evaluate startups that are coming in the door, right? Many of them do, right? So to answer your question, like we are seeing adoption, right? And it will be the players that are adopting the fastest that are going to rise to the top.
And do you see that being the larger construction companies, the medium size, kind of a mix of all of this? Maybe you can even name some that are looking at this, because I think the audience for this show is probably interested in who those people actually are, because that's where they get information. They're interested in knowing more, talking to those people, things like that.
Yeah, it depends on the product, right? So for a product like ours, there's a level of service that's involved. And so we've been focusing on large jobs. We've been focusing on $100 million projects and up, right? There are software out there like PlanGrid, for example, that was selling this thing at, I think it was like $10 per user per month, right? Which is like about the cheapest that you can charge for anything, right? For it to be viable, right? And so, yeah, there's different types of companies will attract different kinds of technologies, right? For us, we're working with Bouygues, with Parsons, with Austin Bridge and Road, with Takanaka. We're on the HS2 project in the UK, the $170 billion rail, with Skanska and several other sort of players. So those are kind of the names. And in our top 400 are the folks we tend to work with.
Yeah, and I mean, it seems like if you're talking about projects that are that size, you're talking about incredible savings for them. I mean, not only in overall cost, but efficiency, speed to completion, all of those things.
Absolutely. Yeah.
Yeah. Wow. Interesting. I mean, there seems to be like, I love that you guys are tackling this, because this, and I would love to see ways for this to make it back into the architectural side of things. Again, I think architects are very hands off on the logistics and the sequencing and things like that. I know that it happens. Like when we're designing something, we are forced to think about how it is going to be put together. I think it would be negligent not to, right? But I don't think it's happening at a deeper level or in a collaborative way with the people who are actually going to build it. And I think a lot of times our models are designed, like we talked about earlier, for one intent, but not necessarily for the intent of the contractor. Those are different worlds for the most part. I mean, it really depends on the project delivery type more than anything. But I think that there's still a huge gap between those, where we could be and where we are now when it comes to working this type of problem solving into the project at the earliest stages of design, so that we're making really smart decisions as we go through, because these decisions, if they're made later, they cost a lot more.
Yeah. So I think that if you look at the way construction has kind of evolved, right? You know, if you look back at like the pyramids or the European cathedrals, right? You have this concept of like the master builder, right? This thing that I got to experience in Afghanistan, where like you are the architect, the structural engineer, the plumber, the procurement manager, the construction manager, and all the above. And I think as construction projects have gotten more and more complicated, we've broken these, tasks into specialized companies and specialized people, architects, construction managers, and so on and so forth. What's interesting about the technologies that are emerging, and really they're kind of bubbling up around our feet, as we're speaking, is that what they fundamentally do is they change the economics of the equation. And so the cost to create an option is 10,000 times less. The cost to create a drawing, the cost to create a schedule, the cost to create an estimate, the cost to change the design, like whatever it is that you're looking at, the cost to integrate across systems, right, changes. And so as these technologies start to change the economics of this, there will be some really interesting shifts, right? Because at some point, somebody's like, wait a minute, maybe what I can do is integrate these functions that have been specialized and separated in the past, and they can integrate them into one using these technologies. And so I believe that will start to happen as we move forward. Yeah.
Yeah, absolutely. It's interesting to think of people having enough information to become that quote unquote master builder once again, that orchestrator of these things, which is being leveraged through technology that you're talking about. The ability to have that kind of dashboard of the entire process is getting closer and closer to reality. And it is kind of opening a window back into that idea of master builder as this kind of master orchestrator of the entire process. It's very interesting.
Yeah. We're living in the most exciting period in construction in the last really maybe 2 millennia. What's really interesting about it is that every single person in construction can play this game, so to speak. That's something like originally I was like, oh, we're like working on this like cool cutting edge AI stuff. Like if you're a scheduler, if you're an estimator, if you're a site engineer, right, at a construction company, right, there are literally thousands of research and R&D departments at your disposal that call themselves startups, right? And the construction company of the future will be successful based on three things. How effective are they at identifying these startups, these R&D departments, evaluating and then integrating them, right? Because you're looking at literally, I think it was $1 billion of venture capital that's being poured into developing these technologies and ideas. And so now it becomes a question of like, do you combine these two or those four? Or how do you piece this together? It's incredibly exciting.
Yeah, talk about recipes, right? Like that's recipes on a different level rather than on the one project, but as like the overall ecosystem that you're kind of creating. And it does seem like when you talk about this kind of democratizing of technology to the users, right? You say anybody can use this. I think that's what's so interesting about a lot of the technology that we're seeing is that it doesn't care who the users are. It's trying to give them leverage over these problems that they deal with all the time. And it doesn't need to be exclusive.
That's what I love about innovation, right? It's like, construction is not innovative. Bullshit. I can tell you, I can show you a client list, right? Like there is somebody somewhere out there that's thinking to themselves, my company's number 200 on the NR list. I want to be in the top 100. There's someone that's thinking, hey, in Chicago, we're the third largest contractor. I want to be the biggest in Chicago, right? Like there's somebody somewhere out there that's hungry, right?
Absolutely. And it's so interesting to me that you bring up these lists because I think there's a lot of companies who are pretty far down on the list and they want to talk about it on social media. Like we're number 23 on the list. And it's like, nobody wants to talk about anybody who's not the top 3 or 5 on the list. So how are you going to get there, right? And I think it is by putting together these puzzle pieces and creating this innovation ecosystem for your business to really move into one of those positions. And then you're talking.
Absolutely right. I mean, it's how do you leverage all of this investment, this money? Like, how do you harness that? Right. And it's something that will basically move your company forward. Right. And it's,
yeah.
I mean, I like, truthfully, when I look at these construction companies, like, I'd take that job any day. I literally, like, I get excited just thinking about it. Right. I've talked to our clients. I'm like, yeah, anytime you guys are thinking about how to build this innovation ecosystem, how to integrate these processes, how to develop the new set of processes, like, it's super exciting. And I've done it when I was doing that 6 month on, 6 month off, like when I was doing the 6 month of work, like, I really learned what it takes to innovate at a company, right? And how to build like a critical mass of people. And you start with one person, then 2 and 3. And, we had like a scheduler and a project manager. And suddenly we had like one person from each of the sort of disciplines and this kind of little team. And then we started, like, originally people laughed at us, like, bam, you guys are bringing the Silicon Valley crazy, technology to us. We're in this little village in the Netherlands, right? And then next thing you know, it was like, whoa, these things are really cool, right? And exciting.
You're firing on all cylinders when you got all of those different people.
People start to add to that team. Right. Now, can we get some of it? And like, yeah, it's fun.
It is interesting that you have to create those scenarios where you're showing that progress, you're showing that winning and then other people start to see it and they start to get on board with it. And you basically prove it in small bursts along the way, and you pick up momentum by doing that. Yeah.
Yeah, absolutely. And you get to play with some, like, my buddies that I graduated with, right? Innovation manager at, DPR, for example, right? Like, I talked to him and they're like, yeah, we're playing with robots, like, what the heck? Like, when did that happen for construction, right? Like, Canvas, you've got built robotics, you got, like, that's cool, right? You got all the, like, AI, Alice on the generative construction side, you've got all these sort of technologies, like, character recognition stuff, like machine learning. Yeah, it's fun.
Yeah. So what's next for Alice?
Yeah, for us, what we're working on, I think the next will be a release of the field manage, right? And that's kind of, I think, the big next thing for us, right? Like we've got the core engine that knows how to ingest BIM, read it. We've got a 2D version coming out that allows you to run the software without 3D, right? Beefing up, import, export, capabilities with existing software. And field manage, right? The ability to manage stuff directly from the field, like update your progress and say, I finished this, I did not finish that, right?
Excellent. I mean, it all sounds like you've got to go from, like you said, the planning to the doing part of it. And it seems like obviously there's tons of management that goes along with that as well. And it seems like the software can learn a lot through all of the different project types that are out there. There's so much data that it can be learning from as all these companies are going through these processes on these big jobs that will eventually trickle down to smaller companies and smaller jobs and take all this extra little busy work out of it so that people can focus on more important things.
Yeah, I completely agree. I think that what technology does do is it makes life more fun, right? Like computers didn't make our life duller, I would argue, right? Like work still work, right? Like I tell everybody, right? Like there's going to be days where you're like, man, this is like boring. Right? I want to do something else. But if you got 1 or 2 of those days a month, great. If you got 29 of them, like, okay, maybe you want to look at doing something else, right? But that's the nice thing about computers, right? They really eliminate all of that sort of busy work, right? The boring stuff, and let us be creative, right? Which is really fundamentally where I think the human strength lies, right?
I totally agree. Well, I love the optimism, and I appreciate what you're doing, René. Maybe you can just, at the last piece here, just tell everybody where they can follow along with what Alice is doing on the internet, social media, wherever you want to point them to.
Yeah, alicetechnologies.com, right? alicetechnologies.com, or shoot me an email, René@alicetechnologies.com.
Awesome. I appreciate you taking the time to share and be so generous today. It's been a great conversation.
Awesome. Really great to be here. Thanks for asking such great questions, Evan. Thank you.
Thanks for listening to the Troxel Podcast. And once again, I would like to thank ARC IT for sponsoring this episode. Visit their website at getarchit, that's GETARCHIT.com. Thank you to Avail for their support of this podcast episode. Visit getavail.com to see their holistic approach to content management today. Thanks to NCARB for their support of this podcast episode. Visit ncarb.org/AOP and contribute to the Analysis of Practice survey today. This show is part of the Gable Media Podcast Network. You can see all the shows at gablemedia.com. That's GABLMEDIA.com. You can help support what I'm doing here by leaving a 5-star review on Apple Podcasts to help get the word out, and of course, share it with your friends. I'd love to hear from you, so leave a comment on the website at trxl.co/podcast, where you can find every episode. You can also follow me on Twitter and Instagram and YouTube. Just search for eTroxel. Talk to you soon.